In order to understand the influence that the administration of IV fluids and blood products had on Murphy's recovery, I think it is important, Mrs. Williamson, that first we revisit what was wrong with Murphy and what his body was doing in order to combat this. So as you know, poor Murphy had what we call a splenic haemorrhage. That means that he was losing blood out of his spleen. The blood is an important fluid as it contains many cells and proteins. Red blood cells are particularly important as they can transport oxygen around the body. With Murphy's blood leaking out of his spleen, there is less of it travelling around in his veins and arteries. With less blood moving around the body, there is less oxygen able to be carried around to the tissues, the muscles and the organs. These tissues become starved of oxygen so they cannot function normally, and this is why Murphy collapsed. In order to try to combat this sudden blood loss, Murphy's body has a few mechanisms that it put in place to try to restore blood volume and blood pressure. The loss of blood from the spleen has caused a reduction in blood pressure. This fall in pressure is detected by special receptors found in his neck, called baroreceptors, and causes activation of what is known as the renin-angiotensin-aldosterone system, or RAS. Without going into too much detail, as you can see in this flowchart, RAS causes production of angiotensin II from other proteins and enzymes. Angiotensin II has many different mechanisms of action, all of which aim to increase the sodium and water retention within Murphy's body. What this actually ends up doing is dilating the blood. Whilst we have a temporary fix because the blood volume is restored, we aren't replacing the loss factors such as cells and proteins, and thus the blood's ability to carry oxygen is greatly reduced. The best way that I can think of to explain this is with an analogy. Consider this. Here we have 2 glasses with Ribena. The Ribena represents Murphy's blood. If we pour some of the Ribena out of this glass, this represents what was happening during Murphy's hemorrhage. He was losing blood out of his vascular system. When the volume and pressure of his blood got so low that RAS was activated, his body started to conserve and retain water. As you can see, the addition of so much water dilutes the blood. We are increasing the blood volume back to normal levels without returning red blood cell counts or protein levels back to normal. Dilution of blood in this way led to a number of additional problems. You may remember, Mrs. Williamson, that when I first examined Murphy, I found he had a heart murmur. This heart murmur is called a haemic murmur and is caused by the reduced viscosity of his blood. Because the blood has fewer cells, proteins and other factors floating around in it, this makes it more turbulent. Turbulent blood flow can be heard through my stethoscope, and this is what we know as a heart murmur. Murphy's heart murmur thus only arose as a result of his blood loss. In addition, in order to exchange fluids from the capillaries to the organs and tissues, forces act on the capillary to drive fluid movement either into or out of the blood vessel. As you can see here, hydrostatic forces are those moving fluid out of the environment, and oncotic forces are the result of proteins within the fluid dragging more fluid back into the environment. However, because there are fewer proteins being carried in the diluted blood within Murphy's system, the oncotic pressure is greatly reduced, so less and less water is being drawn back into the vascular system, which can result in pooling of fluid in other areas such as the abdomen or lungs, a phenomenon known as edema. In order to treat Murphy, we did a number of things. Whilst he was having surgery, he was also administered with a number of factors, bloods, frozen plasma and IV fluids. The plasma was particularly important as it had a number of uses. Firstly, it contained clotting proteins, which will prevent the leaking of blood through the affected areas by forming small blood clots. Secondly, the addition of proteins will increase the oncotic pressure within the vascular system and will thus reduce the further loss of blood through the filtration out of the capillaries. The addition of red blood cells also increases the oxygen carrying capacity of the blood. The tissues are thus better oxygenated and able to function normally. Finally, the increased cell count increases the viscosity of the blood and thus reduces the impact of the heart murmur. If we come back to our analogy with the Ribena, we see that when we lose blood and then we replace it instead with plasma and more blood, so more Ribena, we then achieve a greater blood volume, but it is more concentrated, it contains more cells, more proteins and more clotting factors, and it enables Murphy's body to more effectively recover. Mrs. Williams, I hope I have been able to show you exactly why we needed to provide Murphy with these treatments in order to aid his recovery. The addition of plasma, blood and IV fluids enabled Murphy to increase the oxygen carrying capacity of his blood. The increased plasma protein levels will help to clot the blood. They will also increase the oncotic pressure within the vascular system and thus reduce further fluid loss. And finally, They will act by reducing the turbulence of the blood, thus resolving the haemic murmur which we had observed in Murphy. He should make a great recovery now, and I look forward to seeing him happy and thriving again soon.